We have an exercise here that asks us to explore the inverse relationship. If f of x is equal to x to the fifth plus x cubed plus x, then we're asked to find inverse of 3 and f of f inverse of 2. If f is 1 to 1, then we're guaranteed that there is only one input that'll give us an output of 3. And remember, that's what f inverse of 3 is. In words, we might think of this as what x value gives an output of 3. So we can set f of x equal to 3. As an equation, that would be x to the fifth plus x cubed plus x is equal to 3. Now again, this is valid if f is 1 to 1. So let's ask if it is. We could try graphing it to see if it passes the horizontal line test, but I like to use calculus for stuff like this. This is calculus after all. Taking a derivative gives us that f prime of x is 5x to the fourth plus 3x squared plus 1. Now here we have a term 5x to the fourth, never negative, 3x squared, never negative, plus 1. And so the derivative is always greater than 0, which means that f is always increasing. Then we know it passes the horizontal line test, and f is 1 to 1. Now let's return back to this equation that we have. It's a fifth degree polynomial, x to the fifth plus x cubed plus x equals 3. And we have a way of solving a fifth degree polynomial. Remember from pre-calculus, you use synthetic division and do all kinds of stuff, but I'm going to say that by inspection, which basically means we looked at it, we can conclude that x is equal to 1. Now you may wonder, well, how would I have known that? But first let's verify this. If x is 1, then 1/5 plus 1 cubed plus 1 is equal to 3. There it is. So after you see the answer, then you realize it makes perfect sense. And since f is 1 to 1, this is the only such x value that works. But then again, how would you know this? I'm going to recommend that for exercises like this, we're going to look for like x equals 0, x equals 1. Look for obvious values there. So since 1 is the output associated with 3, we know that f inverse of 3 is equal to 1. As far as the other bit, if we want f of f inverse of 2, I'm going to use some words here. There's a number that when I put it into f, I get an output of 2. What happens if I put that number into f? I get an output of 2. Another way to look at this is that the function undoes what the inverse does. Visually, we can say that 2 is part of the range. It maps to an element f inverse of x. Now, f inverse of 2, f would map that number to 2. So there we are there. And I think I would be leaving something out if I didn't point out this is valid because we've already established f is 1 to 1. Find f inverse prime of a for f of x is equal to x cubed plus 3 times the sine of x plus 2 times the cosine of x, and a is equal to 2. Remember that f inverse prime of a is equal to 1 over f prime of f inverse of a. So we need these two pieces. One of them is f prime, and the other is f inverse of a. Let's start with f inverse of 2 this time. So for f inverse of 2, we want to set the function x cubed plus 3 times the sine of x plus 2 times the cosine of x equal to 2. And this would be very difficult to try to solve generally because we have a polynomial term, x cubed, and trig terms. Those become very difficult to solve. We could do it using Newton's method or something. Or we could look at it. Remember, we're looking at things that are generally like x equals 1, x equals 2, x equals 0. And in this case, it turns out if x is equal to 0, then f of x is equal to 2. And I observe that because we have a factor of x cubed and sine of x. Both of those are 0 when x is 0. Cosine of 0 is 1. We end up with 2 equals 2. So f inverse of 2 is equal to 0. Now we go for f prime. F prime is going to be 3x squared plus 3 times the cosine of x. Here's the minus 2 times the sine of x. It follows that f prime of f inverse of 2 becomes f prime of 0, which is equal to 3. Because again, putting 0 in place of x, 0 is out the 3x squared and the 2 sine x terms, and the cosine of 0 is 1. I'm going to back up just a moment. Back here when we looked at that f inverse of 2 is equal to 0, we did this by inspection. We looked at it. All right, now we're going to put what we have into our formula. F inverse prime of 2 is equal to 1 over the answer that we got from f prime of f inverse of 2. And so in this case, the answer is 1/3.